Okay, now I want to discuss one example of the full wave rectifier. Okay, let's consider a circuit. This is AC source and then connected with the center tap transformer. So let's consider a center tap full wave rectifier. So center tap full wave rectifier. This is center tap has two diodes and then it's connected to the RL. This is V out, and then let's say the turn ratio is primary is, let's say, 10 to 1, and then here the input is VRMS equal to 100 volt, and then frequency is equal to 50 Hz. Okay, so the question is draw waveform at the first one at secondary of transformer, and then the second one draw waveform at the output. Okay, so the waveform, the provided information in terms of the voltage is VRMS. So VRMS is actually average voltage. So when you want to draw the waveform, you need to calculate the V peak. So first, calculate the V peak of the primary. V peak of the primary is square root 2 times VRMS, 100. So this is how I get this equation. This is the relationship between V peak and VRMS. So this is square root 2 is 1. So we get 1 for 1.4 volt. So this is at the primary. And then this is at secondary. Okay. Actually, the question number 1 is not clear because we have two secondary point for the center tap. So let's consider the secondary type point at this point. I put this point A. This is point A. So when you see at the point A, the secondary at the secondary transformer, you need to calculate the V peak of the secondary. So V peak for the secondary is equal to N secondary over N primary times V peak primary, and then it needs to be divided by 2. Okay. Why divided by 2? Because this is a center tap. Center tap need to divide it by 2. So the N secondary is 1, N primary is 10, and then V peak primary is 141.4 times 1 over 2. So you will get the value. The value is 141. Okay, let me calculate this one. 141.4 divided by 20. So you get 7.07. 7.07 volt. So this is the V secondary. Okay. So for the second part, for the output voltage, okay, you need to calculate the V peak output. So the V peak output is equal to V peak secondary minus 0.7. So this is 7.07 minus 0.7 equal to 6.37 volt. So now you know, you get the value for V peak secondary and you get the value for V peak output. Okay, so the next is you need to draw the waveform. Okay, for the number one is there is no rectification involved, so the output will be in sine wave. Okay, so since the frequency is 50 Hz, so the period is 20 milliseconds. So the period is 1 over 50 equal to 20 milliseconds. Okay, so here you need to be careful because the secondary, for the center tap, you have two secondary. For the lower secondary, the point A, this is the inverse value. So the waveform should be something like this. This is negative 7.07. This is 7.07. So this is voltage, and then this is 20 milliseconds. So this is the answer for number one. For the number two, you know this is the full wave, so you can draw the shape of the full wave rectifier. So this is 20 milliseconds, and then the peak voltage is 6.3 volt. So this is the output voltage. So this is the answer.